Hi guys, welcome back to my channel, Pirai Academy. In the series of data structure playlist, today we are going to see about queue implementation. So it is just going to be the normal queues, okay? And in the previous video itself, I have told you that ADTs of queues, those NQ, PQ and peak, right? So now let's get started. Initially, just just assume the queue size is 5. For example, okay, the queue size is 5. So this is going to be a queue and its size is going to be only 5. Now initially NQ of 5, which means you want to just push 5 into it. Okay, pushing 5 into it. Again NQ of 4. So push 4 into it. Again NQ of 22. Push 22 into it. 21. Push. Again 100. Push. Now NQ of 5, which means I want to add or I want to insert another element. But already we have 5 elements. So we cannot do this because our queue is full. Because our queue is full. Can you understand this? Okay. Now the next operation is going to be DQ. So when I am going with the DQ, the first element that is inserted will be taken out first. So this 5 will be removed. Okay. Again NQ of 100. Now I have a capacity to add, right? Only 4 elements are there. So I'll be adding 100 into it. Okay. Now again I am doing a DQ. 4 will be removed. Can you understand this? Okay. Now peak. Peak means I want to tell them the top element. What is the top element? It is 22, right? So I'll be just telling the value as 22. I don't want to remove the 22. Okay. Instead, I will be only telling that value is 22. That's it. Can I understand this? Okay. Now DQ. So when I'm doing a DQ, this 22 will be removed out. Again, I'm going to do 4 times the DQ operation. At first time, this 21 will be removed. At second time, the 100 will be removed. At third time, this 100 will be removed. At fourth time, the queue is empty. So here, we don't want to do anything. Rather, I'll be just telling, hey, the queue is empty. Can you understand this? Yes. So there are only two things. One is queue is full or queue is empty. So now hope you understand what is the implementation or how we are going to do the implementation of queue. Okay. So there are two types of implementation or we can do it in a two way. So one is using array. Another one is using linked list. So in this array, there is a small disadvantage. What is the disadvantage? So the disadvantage will be like we will be having only the fixed size. We will be having only the fixed size. But here we don't have the any fixed size. Can you understand this? So this is going to be your comparison between arrays and linked list while implementing the queues. Fine. So let's get started with this. First of all, I want to know about this array implementation. Then we can go with the linked list implementation. Fine. So how we are going to implement in the array? First of all, I will be taking a queue here, okay, and I will be taking a array here, so that you can understand this. So 1, 2, 3, 4. 0, 1, 2, 3, 4. So these are going to be your index, and this is going to be your queue. Okay, fine. So the size of the array and the size of the queue will be of size 5. Assume. Now I'll be taking two pointers like a front pointer and a rear pointer. I'll be telling you why we are using this front and rear. Before that, you know about the NQ and the DQ, right? So whenever I am doing a NQ operation, I'll be taking out the frontal. Sorry, whenever we are doing a DQ operation, I'll be taking out the front element. Whenever I am going to do a NQ operation, then we are going to add an element to the rear end on the back side. Can you understand this? So for these two operations, I am going to take a front pointer and a rear pointer, where this rear pointer will be pointing towards the -1 and front pointer will be pointing to the 0. Now hope you understand this. Yes? Okay, let's get started. So at first, let me do a NQ operation. NQ of 5. If I do a NQ of 5, this 5 will be added at the zeroth index, right? So to add this element in the zeroth index, in the queue it will be added just like that. Because in some programming languages, we will be having the inbuilt data structures by using some libraries. Almost in every coding language, we will be having this. So for example, if you are using a Java, you will be having a collections, right? And if you are using a C++, you will be having a SQL. And if you are using a Python, you will be having a DQ. So by using these libraries, you can easily go with the queue data structure. But now we are going to implement it using the array, right? So here this file will be just enqueue or just pushed. That's it. Okay. But here in the implementation, it will be inserted at the zeroth index because zeroth index is the first index that is empty. So how we are going to do whenever it is a enqueue, we'll be going with a rear pointer. So rear pointer is at the -1. Now -1 plus 1 will be what? 0. So now my rear pointer will be moving out here. Moving out here. So here 5 will be inserted. Can you understand this? Okay. Now again, NQ of 10. So rear pointer again move one step forward and 10 is added. Here also 10 is added. Again NQ of say 22. Again rear pointer will be moving here and 22 is added. So here also 22 will be added. Again NQ of 22. So again this rear pointer will be moving forward and 22 will be added. Here also 22 will be added. Again, if I do NQ of something like 100, then 100 will be added here, 100 will be added here. Now, if I do again a NQ, so this rear pointer will be now here, right? Okay. Now, if I use again NQ of 200, now comes to this. Now comes to this. Here, whether we have any other slot behind this index 4? No, right? Already the R pointer is at the fourth index, which means length minus 1 index. So which means it is a last index. So beyond this, there is nothing. There is nothing. So I'll be just telling out, hey, the queue is full. So you cannot do anything. You cannot do anything. Okay. Now, if I do a DQ operation, so now I am going to do a DQ operation. For example, DQ of. Okay. Now, if I use in the DQ, then I want to go with the front pointer. I want to go with the front pointer. So in the queue, you will be just popping this 5 out and just printing that 5. That's it. I understand this. But in your array, what we will be going to do is we will be just taking this front pointer to move here. We will be returning this 5 first, then we will be just moving this front pointer plus 1. That's it. Simple. Can you understand this? Now, if I use peak, which means the first element. Now, I don't move this front pointer. Instead, I will be returning the element at the front pointer. So 10 will be your output. Similarly, here also, in this queue also 10 will be only output. Again, now I am going to do DQ operation for 4 times. For 4 times. For example, okay. Now, at first, this 10 will be removed. Okay. And then my front pointer will be moving out here. At the first one time. Okay. And the second time, in second time, this 22 will be removed here. And here, the front pointer will be returning this 22 and moving the front pointer here. Now, at the third time, this front pointer will be moving here and this 22 will be just returned. Here also this 22 will be removed. Okay. Again, if you do a DQ operation for the fourth time, now my front pointer like this 100 will be returned and this front pointer will be moved to the index 5. Here also this 100 will be removed. Now, see here, again if I do a DQ operation, this is going to be very important. Again, if I am going to do a DQ operation, see here, R is at where? R is at fourth index. But my front pointer is at fifth index, which means my front pointer is greater than my rear pointer. At this time, I can clearly state that hey, the queue is empty. the queue is empty. Can I understand this? Okay. If I do again a NQ of 100, NQ of 100, so this rear pointer is at where is that fourth index. So I cannot do or I cannot insert anything inside this array. Now hope you understand what is the disadvantage in the array. So it is a fixed size. It is a fixed size. You cannot again go back to the zeroth index. If you are going back to the zeroth index, then it is called as a circular queue. Can you understand this? So this is going to be your normal queue. But if you are again going back to the front index, then it is going to be your circular queue. So this is going to be your ADT and implementation of queues. In next video, we will be seeing the continuation of code explanation for this queue. Okay. So now let's see what is the time complexity of each and every function. So this is going to be an important thing. So for this only, I have taught you the basic fundamentals of time complexity and space complexity. Okay. The first operation is friend. For this friend, what is the time complexity? It will be big O of 1. Can I understand this? So, sorry, it means top or peak. Okay, for this, what is the time complexity? It will be O of 1 because we already have the front pointer and we are just taking the front pointer element. That's it. Okay, so it will be O of 1. Now, what is the time complexity of NQ operation? So it will be also O of 1 because we already know at which index we are going to insert it. Okay, so we will be going to that index and inserting it. So it will be a constant time. And then DQ operation. For this DQ operation is also O of 1 because we know it is at the front pointer. So front pointer will be returned and front pointer will be incremented by 1. That's it. So this is going to be your time complexity. And as you know, space complexity will be over n, the size of the array we have already given. So this is going to be your overall time and space complexity analysis. Now we can go into a coding part in the next video. So if you really like this video and subscribe to my channel. Don't skip any videos in this playlist because all videos will be helpful once you are appearing for the competitive programming. And if you have any doubts in this implementation, you can ask in the comment section. I'll be just telling you in a clear manner in the comment section, or I'll be just putting a individual video on it. And once again, thank you for watching it.